Hi everyone, in this video I'll go over the review questions from Module 4. So this is the document that you can find in the final exam review in Blackboard. So remember, Module 4 we only covered sections 4.1 and 4.2, and this was all about linear models. So you should recognize what a linear model is, how it looks. You should also recognize the different characteristics of a linear model. So remember that there is this constant rate of change. You are consistently adding or subtracting the same amount over and over and over again. We also looked at the different parts of the graph, like the slope and the vertical and horizontal intercepts. So in the questions that you see here, you'll get a good sense of what it is you're expected to know for the 7th assessment and also for the final exam. So let's take a look at number 1. It says the company executives at Company A are very happy that the company is growing. The company plans on adding 25 new employees each month for a while this year, maybe for several months. Company B, however, is downsizing. It plans to lay off 15 employees each month for a while this year, maybe for several months. Could the number of employees E at either company be modeled by a linear equation based on months M? So for this question, what you need to ask yourself is the change that's happening an addition or subtraction, and is it the same addition or subtraction every single instance in terms of the situation? So in this situation, we're talking about changing the number of employees each month. And we want to know, are we changing the number of employees by adding or subtracting in the same exact way? So for Company A, they are adding 25 new employees each month. So we're adding the same amount, that is that constant change of plus 25. So Company A could be modeled by a linear equation. For Company B, they are downsizing. They are laying off 15 employees each month. So that means that they're subtracting 15 from their number of employees that they have every single month for a certain period of time. So even though it's a subtraction, it's that constant rate of change. They are subtracting the same amount every single month. So Company B could also be modeled by a linear equation. So we're looking for the choice that says that both of them could. Both companies could use a linear equation to model the number of employees E after M months. So that would be this choice here. So I'll just write that on the side here. So question 1 would be choice C. And again, for Company A, that constant rate of change would be plus 25, and for Company B, that constant rate of change would be minus 15. Both are linear. Taking a look at question 2. A new college opened in 1990. It started with 730 students. By 2010, the college had 3,590 students. Assume the growth of the student population can be modeled with a linear equation. What would be the slope of that equation? All right, so here what you need to remember is how to calculate slope. So when you're calculating slope, there's a formula that you need to have memorized. So this formula was m equals y2 minus y1 over x2 minus x1. And this is for two ordered pairs. So the first thing we need to do is identify two ordered pairs from this situation. So the first ordered pair comes from the year 1990. So just like we had seen in the milk and soft drink consumption unit, the year would be the independent variable. So the first ordered pair in 1990, the college had 730 students. The second ordered pair in the year 2010, the college had 3,590 students. So those are your two ordered pairs. We're going to use both of these ordered pairs in the slope formula. It might be helpful for you to label your ordered pairs x1, y2, x2, x1, y1, x2, y2, so that you can easily substitute them in the right place. So here m equals, my y2 is 3,590 minus y1, 730, divided by x2, 2010, minus x1, 1990. So from there, you're just going to go through the operations, subtract, the numerator and denominator, and then divide. All right, so subtracting the numerator, get my calculator here. I have 3,590 minus 730. I'll write that underneath. So that's 2,860 on top. And then for the bottom, that's over 20 years. Even though in this example, looking at the answers, the units aren't there, but I want you to keep in mind what the units would be. So in this case, it would be students in the numerator and years in the denominator. So it's a change of 2,860 students over 20 years. And when we divide, we get the unit rate, the number of students per year. So this would be 143 when I divide those two numbers. That would be students per year. So in this example, the units weren't needed, but you will have to use the units to describe the meaning of slope in some of the questions. So here's just another example where you can practice that. So we would see the correct choice be 143. Let's take a look at number 3. Sorry about my background noise there. Question 3 is asking us to determine the correct linear model based on the situation. It says Yana's yogurt store sells a cup of yogurt for $4 and charges 75 cents for each additional topping. Which equation below gives the price of a yogurt Y with T toppings? So here we need to think about the first independent and dependent variables. So we're talking about the price of the yogurt and the number of toppings. So the price of the yogurt is going to depend on what you put on it. So Y should be your dependent variable. So we're looking for equations that start with Y equals. So let's write this off to the side here. So question 3, we know we want to have a Y equals. So we need something times T plus something else. All right, so I have it narrowed down to either choices A or B right now. So let's go back. So T is the number of toppings, and we're told in the description that it's 75 cents for each topping. So I would multiply the number of toppings by the 75 cents, and I'm going to write the 75 cents in dollar form, so 0.75. The amount that we put here, the constant, is the starting amount, like how much is yogurt without any toppings. And in this case, a yogurt is $4 without any toppings, so we would put a +4 here. So taking a look at the choices we have, B would be the correct choice for this situation. Okay, here, so for question 4, it says an online movie service charges $5.99 per month to stream movies or TV shows. Streaming means that customers can watch the movie or TV show on their own computers, iPads, or TVs. Customers can stream most of their favorite movies and TV shows as often as they want to see them. But if the movie is a new release, that is, it has recently been out in the movie theaters, the company will charge an extra $1.99 to stream it. The following table was created to demonstrate how much the movie service will cost its customers. Identify the missing values. All right, so in this situation, we could use the table to fill in what we are missing, or we can also write a linear model to demonstrate the situation. Also, based on what we are given, let's let C be the total cost. So this is question 4. Let's let C be the cost of what you'll be paying for that month. So that would be the second column here. And let's let N be the number of new releases. So you are paying $5.99 per month. and then $1.99 for each new release. So the $1.99 gets multiplied by the number of new releases, and then you're adding the monthly fee to that. This is like the data plan example that we saw in 4.1. So what you could do here is use this equation to fill in the missing pieces. So for the first row, we have 0 new releases. So we're replacing the N with 0. In that situation, 0 times $1.99 is $1.99. Excuse me, 0. So we're just left with $5.99. So we would fill in that first row of $5.99 in here. So this is for when N equals 0. For the second row, everything is filled in for us. The third row here, the total cost, C, is $9.97. So we want to find what N is when C is $9.97. So taking this equation, I'll just rewrite it for a moment. We are replacing the C with $9.97, and we're looking for N. So here, since N is not isolated, we want to solve that. So the first thing we will do will be to subtract $5.99 from both sides. So this gives us $3.98 equals $1.99 times N. And we'll go ahead and divide by $1.99 on both sides, which gives us a value of 2 for N. So in the third row, this would be for 2 new release movies viewed. And then finally, the last row, we are missing C again. We have N is equal to 5. So for there, we can just go ahead and plug in 5 for N and go through the order of operations, because C is already isolated there. So I'm multiplying 1.99 times 5, and then adding $5.99 to that, which would give me a total of $15.94. So the $15.94 would be in this last position here. So again, because of the linear model, when we were looking for the cost, it was just going through the order of operations, or using the equation that we had written from the beginning. And when we were looking for N, we had to go through the process of solving, right? Looking for undoing those order of operations. So it just depends on whether or not the variable you're looking for has already been isolated or not. All right, we'll take a look at the remaining questions in the next video.